All right, hello. Thank you for joining me for this video. This video is going to be on different types of angles. There are 1, 2, 3, 4, 5, 6 different types of angles that will be covered in here. It is highly important if you are in a geometry class and you are learning geometry, Euclidean geometry. It is highly important that you have a basic understanding of these general types of angles so that you can then apply them along with algebra um, to solve some problems. So to hop into this, we have adjacent angles. Now, adjacent angles, the word adjacent means next to. So when we talk about adjacent angles, we're talking about angles which are right next to each other. And in this case, adjacent angles means that they have a common side. They share a side. So I have two angles that share this side, which happens to be ray MB. So they share a side. They share this ray MB. So I have this angle here. Highlight the interior of it. So I got that angle there. That's the interior of angle AMB. And then I have this angle there. So I have two angles, and they are adjacent to each other. And I actually have three angles. So I'm also going to go over how to name angles. There are three different angles here, right? We have the blue angle. We have this pink angle, but there's also, if you watch my video on angle addition postulate, these two angles add to create this whole angle, which is CMB. So the three angles that are here are, we have angle CMB, we have angle BMA, and then we have angle CMA. Now, you could do angle BMC, angle AMB, angle AMC. The key point here that's really important also when naming angles is that the vertex is always in the middle. Your vertex is always the middle point when naming an angle. So your vertex always needs to be in the middle when naming the angle, and then use the other 2 points. So CMB, BMA, AMC. Vertex needs to be in the middle when naming the angles. And they are adjacent. They are right next to each other. They share a common side, a common ray in this case. All right. So if I was to do the angle addition postulate on this problem, and let's say that this is angle 1 and this is angle 2, I would say that the measure of angle 1 plus the measure of angle 2 equals the measure of the whole angle, which would be AMC. So the little, right, if this was like 20 degrees and this was 50 degrees, then the whole thing from here all the way to here would be 70 degrees, because 20 plus 50 makes 70. So adjacent angles. And then there are some special types of adjacent angles. So down here we have a bisected angle. The word bisect means to divide in half. So this means to divide in half. So I have a bisector here, and it's the shared side. I have a bisector that's bisecting the angle ZWX into two congruent parts. That's what those tick marks mean. So I have this angle that's being bisected into two congruent angles, So if I'm getting two congruent angles, that actually means that the measure of angle 1 is equal to the measure of angle 2. Because they're both halves, right? 50% is equal to 50%. A half is equal to a half. So if I know that an angle's been bisected, I know that this half is equivalent to this half. So if you were ever to get a problem that said this side is 45 degrees, which in this case is not very accurate. Let's say 85 degrees. Let's say this side is 85 degrees. That means that this side is also 85 degrees because they are both halves. Because if this is 85, then this is 85, which would mean that the entire thing, you just add them together, right? Using the angle addition postulate, that if this piece is 85 and this piece is 85, then the whole thing from here all the way to here would be, what is that? It's 170 degrees, which I don't think is this isn't drawn to look like 170 degrees, but the point is that it's bisected. So special adjacent angles are bisected angles where the two adjacent angles are both equal halves because it's been bisected, it's been cut in half. All right, another thing you might see, do I have another color? Gotta have a purple pen around here. Let's grab a purple pen out. All right, so another thing you might see is maybe like 2x plus 4 over here and maybe 5x minus 30 over here. Well, what's special about this side and this side? Over here, I said that the two angles are equal to each other. So what I could do is I could do substitution of, okay, measure of angle 1 is 5x minus 30. So I could do 5x minus 30 equals, oh, well, measure of angle 2 is 2x plus 4. Oh, 2x plus 4. And then you could solve for x. And I could go through and I could solve for x. I don't think this problem would work out very nice, but you could go through and you could then solve for x. And I'll make a video explaining these types of problems, doing a few examples of these types of problems. But the point is if you have bisected angles, you can set them equal to each other. You can set this half equal to this half. All right, so move on from that. Let's go on to some other types of angles. We have some more special adjacent angles, and these come in the form of a linear pair. So a linear pair, let's get to the root of some words. So linear, this is going to mean line, and pair means two. So we have two angles that form a line. That's what a linear pair is, two angles that form a line. And they have to be adjacent angles. So it's two angles, two adjacent angles that together form a line, which in this case, right, we have this angle. We got this angle. And then we have this other adjacent angle. And together, they form a line. So they're a pair of adjacent angles that form a line. Now, what's special about a line? Well, what's special about a line is 180 degrees, because this angle EDG is a straight angle. Meaning it equals 180 degrees. So straight angles are 180 degrees, and a linear pair forms a line, which creates a straight angle, which means it is therefore 180 degrees. So from here all the way to here, we have a 180-degree angle. So what we get is, we get this little angle, which let's call it angle EDF. So the measure of angle EDF plus the measure of angle FDG. So the pink angle plus the blue angle equals 180 degrees, because when I add them together, I get 180 degrees because the whole thing is a straight angle, which is 180. And now I can do math with this. Knowing this information, I can solve for some missing angles. So like, if I knew that this angle was 50 degrees, oh, well, if this whole thing is 180, what do I need to add to 50 to get to 180? Oh, well, this has to be 130 degrees then, because 130 plus 50 is 180, which makes the whole thing. Another thing, just like in the previous example I did, is there could be maybe some algebra thrown in. Maybe this angle is 2x, and maybe this angle over here is 4x plus 30. And maybe you have to take these and you have to substitute them in. And knowing EDF is 2x, I can say, oh, okay, well, EDF is 2x, so that's 2x plus, okay, well, FDG is going to be 4x plus 30. Okay, so 4x plus 30. Oh, and this all equals 180. Now I have an equation which I can use to solve for x. So then I would solve for x. So you can take this basic understanding of geometry, this basic understanding that if I have a linear pair, that means that the adjacent angles add to 180. I can take that general info, and with algebra using substitution, I can then solve for missing pieces. I can solve for missing angle measures. So that's really important that you understand that a linear pair are two adjacent angles, like this blue and pink angle, that add to 180 degrees. This kind of leads into supplementary angles, because supplementary angles means two angles that add to 180 degrees. So if supplementary angles are two angles that add to 180, well, didn't these add to 180? Yes. So this is also special supplementary pair. Because a linear pair is supplementary adjacent angles. But supplementary angles do not always have to be adjacent. Supplementary angles are just two angles that add to 180. Any two angles that add to 180. So I can have two angles that are totally separate of each other, but oh, well, that's 45 degrees and that's 135. If I add those together, if I take 45 plus 135, I get 180 degrees. Therefore, these two angles are supplementary. Another thing is, if you get a story problem that tells you these two angles are supplementary, and maybe this one over here is, let's say, 35. If you know they're supplementary and you know one of them's 35, what does the other one have to be? Okay, well, 35, and let's say this one over here is x, because we don't know what it is, so we give it a variable. So 35 plus x has to equal 180. Oh, well, I subtract 35 across and I get x equals 145 degrees. So there's, again, ways that if you understand this basic geometric concept, that supplementary angles are two angles that add to 180, whether they're adjacent, like a linear pair, or whether they are apart, whether they're on two totally separate polygons, Whether they're on two totally separate pieces of paper, it does not matter. If you get something that says they are supplementary, you know you can take angle A and angle B and add them together to get 180. And then you can do some math to find a missing component. This leads into complementary angles. So complementary angles are two angles that add to 90 degrees. So supplementary add to 180, complementary add to 90 degrees. Now again, just like supplementary angles, we can have complementary angles that are not next to each other. They aren't even close to each other. But they do add to 90. 25 plus 65, 25 plus 65 equals 90 degrees. So these are complementary. But we have this special case, right, where we have these adjacent angles again. And hopefully everybody knows what this little right square in the corner means. It means that this is a right angle. And a right angle is 90 degrees. So these two angles, this angle here, doing a terrible job shading that, and this angle here are adjacent angles that add to 90 degrees. So I could say if I said this was angle 1 and this was angle 2, oh, well, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So therefore, they're complementary because they add to 90. And I know they add to 90 because of this little square down here. It means that this is a right angle, and a right angle is 90 degrees. This is a lot of info. There's actually one more, which gets even a little bit more fun, that applies to multiple different things. But you need to have the general understanding of these different types of angles. Complementary adds to 90. So if you know they're complementary, if you know they add to 90, then you can do some math with them, right? If I knew that this was x plus 3 and this was 40, then I could do, okay, well, this is angle 1, so I could do x plus 3 plus, okay, measure of angle 2 is 40, plus 40 equals 90. I could then solve for x. Right? If you know the general understanding of the word, of the vocab, of the concept of complementary, you can do math. If you know the general concept here, you can do math because you can create an equation that equals 180. You can create an equation that equals 90. All right. Moving on to some more fun stuff. And this is the last one of this video. Vertical angles. So vertical angles are angles that are opposite each other, and basically they're non-common sides, or their sides are opposite rays. They're just made out of opposite rays. I like to just think of it as an X. So how I like to think of this is if I have angle 1, 2, 3, and 4, angle 1 and 3 are vertical angles. Angle 1 and 3 are vertical angles. And angle 2 and angle 4 are vertical angles. Vertical being they're directly opposite of each other, and what's special about them is this angle is congruent to this angle, and this angle is congruent to this angle. So vertical angles are congruent. So vertical angles are congruent. Now, how you can use this is if I actually have one of these angles, I can find the rest. So if I knew that this was 30 degrees, oh, well, angle 1 is vertical of angle 3. So this also has to be 30 because if they're congruent, they're equal. So vertical angles are congruent, which means they're equal, so 30, 30. Okay, well, now you can use some information that I just went over, and I just went over a linear pair. Isn't angle 2 and angle 3 a linear pair? This pair of angles makes a straight angle, makes a line, they form a line, linear pair. So what do I add to 30 degrees to get 180? 150. Oh, okay. Well, if that's 150 and angle 4 is vertical of angle 2, that's 150 also. Okay, make that a 50. That's 150 also. And then a circle has 360 degrees. So if I was to add all these up, right, I get 150 and 150 and then 30 and 30. And if I added all those up, I would get 360 degrees because there's 360 degrees in a circle. All right, you spin around 360 degrees. So vertical angles are congruent. That's really important information. So you can also, right, you can set up an equation. So what if I know that this angle over here is 5x plus 10 and this angle over here is 70? Well, this angle is equal to this angle because they're vertical. So what if I set up an equation of, okay, if I know the measure of angle 1 equals the measure of angle 3, because they're vertical, then I can use substitution of, okay, angle 1 is 5x plus 10. And the measure of angle 3 is 70 degrees. Oh, what do you know? Now I can solve for x. So there's ways to use this information of, oh, vertical angles are equal. Vertical angles are equal. Oh, what do you know? I got a linear pair. You can use this information to create equations and to solve for missing parts or missing angle measures. I know a lot of info. I really hope this video is helpful though. Like I said, I will most likely be making another video on actually solving some of those equations that I've shown in this video and how you go about solving those and some different types of problems you might get as a student. So thank you for watching, and I'll see you next time.